Welcome to Chatterjee Academy. So this session is for class 10 ICSE revision class, and this is for calorimetry part, and I'll be taking a very short part which is very specific for the exam preparation. Okay. For calorimetry part, first you have to remember Q is equal to MC delta T. So Q means amount of heat required or amount of heat releasing when an object is gaining the temperature or releasing the heat, like if some hot body is releasing some heat to the cold body, okay, and if some cold body is receiving some heat from the hot body. In both the cases we have to release some amount of heat. Either heat is the hot body is losing the heat and the cold body is gaining the heat, and that amount of heat is Q is equal to mCT. M is the mass of the object, C is the specific heat capacity of that substance, and delta T is the temperature difference. Okay. Now there is two terms, specific heat capacity and heat capacity. So heat capacity is that the amount of heat required to increase the temperature of a substance by 1 degree centigrade. Right, and specific heat capacity is the amount of heat required to increase the temperature 1 degree centigrade per unit mass. So there is a basic difference, right? So C is equal to Q by M into delta T, right? And here heat capacity C prime is equal to Q by delta T. So accordingly the units will be like Q for energy is joule. So here specific heat capacity is joule per kg per Kelvin or per degree centigrade, right? So unit of specific heat capacity is joule per kg per kg for mass, and that per Kelvin for temperature or per degree centigrade. Okay. So this way specific heat units you can remember, right? So let me show you a derivation which will really helpful for you. So unit of specific heat is joule, per kg and per Kelvin, right? So it will be joule kg Kelvin, or you can write joule kg per degree centigrade. So Kelvin and centigrade difference is same, right? So delta Kelvin is equal to delta centigrade, because both the scale, the scale difference is 100, right? Now let's do a derivation. Suppose I am having an, let's take a real example. I am having an the ice here. I have ice. Okay. Now what I am going to do, just I want to mix this ice with an water. Okay. Now let's, the mass of the ice is M1, mass of the water is M2. So we will be mixing these two, ice with water. And what are the steps we have to do? So first of all, let's say temperature of ice is minus 10 degrees centigrade, and temperature of water is, let's say, 20 degrees centigrade. Okay. Now what is going to happen? Ice is going to take the heat from water. So water temperature is 20 degrees centigrade. Okay. So it's a high temperature and the low temperature. So heat will flow from water to ice. So water will be releasing the heat and ice will be accepting the heat, right? Then so what are the consequences will be here? Let's say both of them will go to I don't know, the T degree centigrade. So T degree centigrade will be the resultant temperature, right? The net output, like so ice will go to this T degree from minus 10 degree centigrade, and water will go to T degree centigrade from 20 degree centigrade. So obviously this new temperature will be the in between the minus 10 and plus 20. So I can write minus 10 degree centigrade, T is greater than that and lesser than 20 degree centigrade. Okay. So you have to understand this, that this temperature, the new temperature of the mixture of ice and water will be the the between the -10 and 20, right? Now it will be definitely more than 0 degree, because ice is going to, now for this case we are taking full ice which melt to water. And also you can get the question like where partial ice will convert to water. Let's say ice is mixed with 5 degrees centigrade of water. Maybe in that case full ice is not going to melt, part of the ice will be going to melt. So that's a different. So now let's see the steps here. What is going to happen? So ice minus 10 degrees centigrade. First it will come to ice with 0 degree centigrade, right? Then from ice to water at 0 degree centigrade, then water of 0 degree will go to T degree centigrade. So here it will take Q1 amount of heat, here Q2, here Q3. So Q1 will be -10 to 0. Let's say mass of the ice is, let's say M1. So M1 mass, then specific heat of ice, right? Let's say it is C1. So M1 C1 and temperature difference -10 to 0. So 10. M1 C1 into 10. So C1 for specific heat capacity of ice, M1 for mass of ice, and 10 is the temperature difference, the delta T, -10 to 0. This amount of heat ice will receive. Now 0 degree of ice will go to 0 degree of water. So here the phase change happen, like state of matter change. We need the latent heat, right? The latent heat Q will be M2L. So M2 is the, so M2 means the same mass, right? So it will be, we can say it like an M1, same mass. M1L is the latent heat. This amount of heat will be received by ice to become water at 0 degree centigrade. Temperature is not going to change. Latent heat, what it is doing? It is just changing the state of the matter. So latent heat is not going to increase the temperature. It is helping to change the state by the molecular interaction, like intermolecular distance will be reduced and it will become from solid to liquid, ice to water. Then here Q3 is equal to 0 degree to T degree, right? And mass is the same mass. So same mass will go to M, and specific heat of water, let's say it is C2. So it will be C2 and temperature difference 0 to T. So it will be T. So this is the heat required. So total how much heat it is taking? Q1 plus Q2 plus Q3. Okay, plus Q3. So this amount of heat need to be supplied by the water of higher degree. Water of 20 degree is going to supply. Okay, so this you have to calculate. Now this one will be equal to the water. So water, what happened? We have seen that water is going to 20 degree to T degree. So let's say mass of water. So Q4 of water will be, M2 is the mass of water multiplied by specific heat of water, let's say C2, and multiplied by 20 minus T. So this is the Q4, mass of water where ice is going to drop, and the C2 is the specific heat capacity, right, of the water, and delta T, this is delta T, right, change in temperature from 20 to T. Now you have to set the equation. So that will be Q1 plus Q2 plus Q3 will be equal to Q4. By equalizing this, this will be same. We will get the value of T. Fine. So this way you have to calculate. Okay. So you have to understand the steps. So this is an example where ice is mixed with water, and after that it is they are going to a common temperature. Now other case you can get that part of ice melt, and so that melt, for that melting, we have to set a different equation, right? This way we have to go, right? So these are the very general equations for calorimetry part, and obviously this is going to help you, right? And the next part today I will just have a short revision of the the radioactivity, right? So what happened in radioactivity? There is an disintegration happened, the decay happened. It's a nuclear reaction. Radioactivity is an nuclear reactions. So this is not about a totally different from chemical reaction. In chemical reactions, what happened? We have seen that there is an transaction between the electron, and for nuclear reaction, the transaction between the nucleus to nucleus, like nuclear decay happening. Nuclear decay happening, and from there we have, for our syllabus, we have alpha, beta, gamma, right? So alpha particle, beta particle, gamma particle, right? So gamma is like wave, so it does not have the the gamma does not have mass, right? So there is no mass, chargeless. Alpha having the mass of 4 and the charge is +2, and beta is an negative charge, right? So and the velocity part, they are almost same. So alpha, the velocity is 10 to the power 7 meter, right? And beta gamma, it's around 10 to the power 8. So with respect to velocity part, they are very near. But penetration power of gamma is very high, right? Why? The gamma is penetrating much more faster than alpha particle, because alpha particle is losing the energies, right? When you're doing the penetration, they stop very fast. But gamma particle, it's an it's a part of electromagnetic wave, and it is penetrating high, and it's a chargeless. Okay, so this is the basic difference between alpha, beta, and gamma. Okay, so and also what happened, that atom level changes is happening in case of alpha, beta. Whenever, let's say, one alpha particle is coming out, then what is going to happen for that? So uranium is one of the radioactive element. So once an alpha is coming out of uranium, so its mass, both the mass and in the proton number are getting changed, right? So both the mass number and proton number getting changed for uranium decay. Okay, so these are the radioactive decay particle. Now, so we'll get what type of questions you are going to get for. Let me just share you just the property, the difference between alpha, beta, and gamma particle, right? So what happened? There is an alpha emission happen, beta emission happen, and gamma emission happen. So what happened? Like uranium 238 uranium, right? So from this uranium, we are getting a new atom, right, along with one alpha particle. So that is helium, right? Helium 42, one alpha particle emitted, 2 proton and 2 neutron, this one, and it will be the new atom will be 234, right? TH, then 90. So if you see here, both the proton number getting changed and also the mass number. So mass is reduced the 4 and the proton is reduced the proton level 2. So new atom form, right? So this is an example of the alpha emission, right? Then the then what about the gamma? The basic properties that ionizing power. One more important, like ionizing power of gamma is very less, and ionizing power of alpha particle is very high. This is one, and also the gamma particle having the penetration power is very high. That is like much more than the alpha particle. Okay, and regarding the mass, what happened? The mass, the gamma particle is massless, right? In alpha particle, mass of 4, right, and the beta particle mass of an electron. Okay, so these are the very brief, like for radioactivity, and what are the isotope. You can get some question like isotope, like carbon or hydrogen. So isotope means atomic number will be same, and isobar, the mass number will be same, right? So these are the very basic things we have, right? Okay, that's it for today. Okay, so any more questions, please, reach me through my WhatsApp number, reach us to Chatterjee Academy. We are here to help you. Okay, so these are the very basic things, like, will help you, and we are taking the mock test in Chatterjee Academy, right? So every Sunday morning around from 8 a.m. to 10:30 a.m. we are conducting mock test for, physics, chemistry and mathematics. So whoever want to appear the mock test even tomorrow we are having the physics mock test, from 8 a.m. to 10 a.m. right? And after mock test, we are helping you for all the doubt clear. Whatever the lacks you have, we will be sharing you all the model solutions with the concept, right? And which is very required. So most of the conceptual part we have uploaded, which is free for the ICSE board exam. Apart from that, if you need any specific session, like any crash course for class 10 for maybe physics, chemistry, mathematics, please reach us. We can have a 1 week course, maybe offline, maybe online. We can have a 2-3 days courses, and you can attend our mock test, which is going to help you for the the board exam, right? Okay.